Dear students of B.Tech first year, I am Dr. Rohit Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamni Devi Group Institution, Indore. I want to just recall through this lecture number 8 of Mathematics 2 on Unit 1. The last two part of this unit, as one of them is solution of homogeneous linear equation of higher order with variable coefficient and the solution of simultaneous linear equations. So our first part we will see here, solution of homogeneous linear equation of higher order with variable coefficient. So there are two types of homogeneous linear equations which can be reduced to the linear equation with constant coefficient by convenient substitutions. The first type is Cauchy homogeneous linear equations. So what is the general type we will discuss here? An equation is of the type x raised to n of d raised to n of y on dx raised to n plus a1 of x power n minus 1 dn minus 1 upon y of this category is called Cauchy homogeneous linear equations, where a1, a2, a3, n are the constants and while capital X is any function of x. Our first step is to reduce into constant coefficient by using the following steps. So first step is put x equal to e raised to z. Therefore, on taking logarithm on the both sides, this gives to you log of x equal to z equivalent to 1 by x equal to dz by dx by differentiating with respect to x. So now this dy by dx equal to be written as dy by dz into dz by dx. So what will be the value of dz by dx is 1 by x. So 1 by x into dy by dz. Now multiply this by x, cross multiply by x left side. So x dy by dx gives to you dy by dz into d of y, where d is differential operator with respect to new variable z. And now similarly we can obtain this second order derivative and x square d2 by dx square equal to d minus 1 over y. And similarly you can find the value of x cube of d cube by dx cube d minus 2 or y, and so on. We can continue for n terms here, x raised to n of d raised to n upon dx raised to n of d into d minus 1 d minus 2 dot d minus n plus 1. That is, for the last n factor you are having the value is minus n plus 1. Now just on putting all these values in the given equation 1, then it will reduce into the constant coefficient equations as finding the general solution by writing a dependent variable equal to ca plus pi, and then in the last moment you will put in place of z by log of x. Let we come to the understand the second category of problem here is Legendre homogeneous equation is of the categories. In place of simply x we have a factor as ax plus b. So x plus b raised to n, x plus b raised to n minus 1, and dot up to on of y equal to x. So this category of problem is called Legendre homogeneous equation, where a1, a2, a3, n be the constants and x equal to some function of x. So now steps to solve equation 1 can be reduced to linear equations with the constant coefficient by using the following steps as we used in the previous Cauchy case. Similarly we can proceed for a Legendre case. In this place here, in place of x you will put this factor ax plus b by e raised to z by taking log and then differentiating with respect to x. This gives to a upon x plus b equal to dz by dx, or we can say that now dy by dx can be written as dy by dz into dz by dx equal to a upon x plus b of dy by dz. And then similarly we will write here x plus b whole square d2 by dx square equal to a square into d minus 1 over y. And For cubic, you write one more factor here adding as d minus 2, and for nth case minus n plus 1, d minus n plus 1 factors are added. So therefore, on putting all these values in equation number 1, this gives to you convert into constant coefficient, and then you write the complete general solution as y equal to CA plus pi, and then finally we replace z by log of ax plus b. Let me come to an example on this topic here. So suppose this is an example x2 of d2 by dx square minus x dy by dx plus y equal to 2 log of x. Then first of all, since this is a category, you will put x by e raised to z taking log, and then differentiating with respect to x, 1 by x dz by dx you are getting, and dy by dx can be written as dy by dz into dz by dx equal to 1 by x into dy by dz. So therefore x into dy by dx equal to dy by dz equal to d of y, where d is equivalent to d dz. So similarly x2 of d2 by dx square can be obtained as d into d minus 1 over y. Therefore your equation is reduced into constant coefficient in the pattern as d square minus 2d plus 1 over y equal to z. So it is reduces into a linear equation with constant coefficient in terms of z. First we write auxiliary equation m square minus 2m plus 1 equal to 0, a minus b all square equal to 0, that is m equal to 1 comma 1. Therefore the roots are equal and repeated. You write CF as d1 plus c2z e raised to z, and particular integral you will write here capital Z upon f of d. Capital Z is function of z is 2z upon d square minus 2d plus 1. By taking lowest degree term is common, already 1 is already in first term, just shifted this whole bracket in the numerators, and then by applying the expansion here, so 1 plus x is 2d minus d square plus dot 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 for z. Operate this multiply inside z. So this gives to you z into 2z minus d square of z. So that is 2 into z plus differential of z with respect to z is 1. So 2 into 1, and second time derivative when you differentiate z you get 0. So simply the particular integral is 2z plus 4. Hence we complete solution. You can write here y equal to CF plus pi c1 plus c2z e raised to z plus 2z plus 4 on putting z equal to log x everywhere. So c1 plus c2 log of x into x plus 2 log x plus 4. So this is your answer. Now we concentrate one more example of this second category here is solve this equation. So the given equation is 2x plus 1 whole square d2 by dx square minus 2 of 2x plus 1 of dy by dx minus 12 of y equal to d6x. Again by using the substitution here, 2x plus 1 equal to e raised to z, so that log of 2x plus 1 equal to z. By differentiating with respect to x, this gives to you 2 upon 2x plus 1 of dz by dx. So now dy by dx equal to dy by dz, dz by dx equal to 2 upon 2x plus 1 of dy by dz. Then you multiply across by this. So this gives you 2x plus 1 of dy by dx equal to 2 into dy by dz. So that is 2 into d of y equal to d of dz. So similarly you can obtain this second factor here is equal to 2 का multiply होगा तो 4 हो जाएगा 4 into d of t minus 1 over y. Now just substituting these values in the given equation, it will reduce into this constant coefficient form. Then we write the solution here. It is constant coefficient in terms of z. First you write auxiliary equation. So the auxiliary equation is m square minus 2m minus 3 equal to 0. So the roots are factors are m plus 1, m minus 3 equal to 0, that is minus 1 and 3. So that's why CF is roots c1 e raised to 2 minus z is 2 e raised to 3z. Now you can find the pi here. Pi z upon f of d, the value is e raised to z minus d square minus 2d minus 3. Those terms are different functions separating. So e raised to z upon d square minus 2d minus 3. So minus 1 upon 3, 1 minus d square minus 3 to 1 from this raised to minus 1. By taking lowest degree term common minus 3. So this and you shift it into numerator and operate over 1. So this gives to you 3 upon 4 e raised to z upon 1 of d की प्लस पे 1 रखेंगे. सो ये जाएगा 1 स्क्वायर माइनस 2 इंटू 1 माइनस 3. सो प्लस 1 माइनस 1 is plus 1 upon 3 into 1. So this gives to you 3 upon 4 of minus of e raised to z upon 4 plus 1 upon 3. Hence the complete general solution is obtained by writing y equal to cf plus pi equal to c1 e raised to minus z plus c2 e raised to 3z plus 3 by 4 of minus of e raised to z plus upon 4 plus 1.3. Now replace z by x function. So this gives to you c1 of 2x plus 1 raised to minus 1, c2 of 2x plus 1 raised to q, and minus 3 upon 16 2x plus 1 plus 1 by 4. Now we come to the last part of this chapter here as fifth part. How can we solve simultaneous linear equations? First we see the importance of this. So importance of ordinary differential equation arises at the time in which there are two or more dependent variables and a single independent variable. Usually the time t. We consider here only a system of linear equations with constant coefficient, the solution of which can be obtained by reducing the equation into one or more separation variable equations, just analogous to algebraic system of linear equation. So this method is well explained by the following example. Suppose this is an example of simultaneous equation. Under this condition, initial condition, we have to solve this. First of all, we reduce into operator forms the given equation as differential operator form d equal to ddt. So first equation you give to by taking x common, d plus 2 of d over x. So by taking y in terms of y, d plus 1 over y equal to 0. Similarly in second equation you will obtain this. And now just by as we know the elimination method, just like that we are going to eliminate y from equation 1 and 2. So that's why we make the coefficient of y to be identical. So multiply 1 by d plus 3 and 2 by d plus 1, and then subtracting we get here d plus 1 whole square d square plus 1 or x equal to 0. Now we write the auxiliary equation of this: m square plus 1 equal to 0, m equal to plus minus I. Roots are imaginary. How can we write in this case? c1 cos of t plus c2 sin of t. X equal to x is function of independent value is 0. So that's why the numerator is upon operator terms is 0. And the complete solution, that is the value of x, is as the first independent solution is obtained as c1 cos of t plus c2 sin of t. Now eliminating dy in equation 1 and 2 by subtracting 2 from 1, we get y equal to 1 by 2 dx minus 3 by 2x. Just putting the value of x everywhere here and then simplifying, this gives to you y equal to on differentiation minus sin t का differential cos t, second term as it is, by collecting sin term cosine term together. And then by given the initial condition x equal to 1, y equal to 2, when t equal to 0 in 4 and 5, you will get 1 by 1. From equation number 4 you get c1 equal to 1, and by equation 5 you will get c2 equal to 7. Thus the desired particular solution is written as x equal to cos t plus 70 and y equal to minus 11 sin t plus 2 cos t. Thank you very much.